An alien telescope may already have identified Earth as a living planet, not by seeing cities or hearing television broadcasts, but by finding a chemical pattern in our atmosphere that is difficult to explain without life. We have no evidence that aliens are observing us. The real scientific question is simpler. Could Earth be recognized as inhabited from another star system? Under the right conditions, the answer is yes. One way to find Earth is through a transit. When a planet passes in front of its star, it blocks a tiny amount of starlight. Astronomers measure these repeating dips to discover distant planets. The method depends on alignment. For most of the galaxy, Earth never passes across the Sun. It can transit only from a narrow band of space known as the Earth Transit Zone. A study of stellar motion identified 1,715 stars within about 326 light-years that could have seen Earth transit at some point since early human civilization. Another 319 stars will move into that viewing zone during the next 5,000 years. These figures tell us where Earth could be discovered through a transit. They do not tell us whether any of those stars have planets, observers, or advanced technology. For an observer in the correct location, a transit could reveal more than Earth's size and orbit. Some sunlight would pass through the outer edge of our atmosphere. Molecules there would absorb particular wavelengths, leaving patterns in the light. A powerful telescope could search those patterns for water vapor, carbon dioxide, methane, oxygen, and ozone. Scientists call some atmospheric clues biosignatures because they may indicate biological activity. Oxygen is especially notable. It reacts readily with other substances, so it does not simply remain in an atmosphere forever. On modern Earth, photosynthetic organisms continuously replace much of it. Methane is another possible clue. It can come from living organisms, but also from geological activity. Finding methane together with abundant oxygen would be more interesting than finding either gas alone. The gases react with each other, so their continued presence suggests active sources are replacing them. Even that combination would not be conclusive. Natural processes can create both gases. A planet can also gain oxygen after losing large quantities of water. Its geology, temperature, clouds, radiation, and atmospheric history all shape the final spectrum. Alien scientists could therefore face the same challenge we do. They might see a promising chemical pattern, while still having several possible explanations for it. Earth also produces evidence of technology, although these signals are harder to detect than science fiction often suggests. Ordinary television and radio transmissions weaken dramatically as they spread through space. Whether another civilization could detect them would depend on distance, frequency, receiver sensitivity, and whether the signal traveled in its direction. A 2025 study from the Search for Extraterrestrial Intelligence Institute compared several present-day signs of human technology. It concluded that powerful planetary radar is our most detectable technological signal, using equipment comparable to ours. These radar systems send concentrated beams to study asteroids, planets, and other objects in the solar system. Their signals can be far stronger than normal broadcast leakage. However, the beams are narrow and do not operate continuously. A distant observer would need to be in the beam's path, listening at the correct time and frequency. Earth is not broadcasting a steady beacon in every direction. Industrial pollution offers another possible clue. Researchers supported by NASA have studied nitrogen dioxide as a gas that might reveal large-scale combustion. One model examined an Earth-like planet about 33 light-years away. In ideal, cloud-free conditions, a future space telescope with a mirror 15 meters wide might detect modern Earth levels of nitrogen dioxide after around 400 hours of observation. That result comes with major limitations. No such space telescope currently exists. Clouds and airborne particles would make the measurement more difficult. Natural sources, including lightning, can also create nitrogen dioxide. A detection would require follow-up observations before anyone could link it to industry. Humanity is now planning instruments designed to study similar clues on other worlds. NASA's proposed Habitable Worlds Observatory would directly photograph potentially habitable planets and examine their atmospheres. Its goal is to search for combinations of gases that could help distinguish a living world from a lifeless one. Could a civilization older than ours already have more capable instruments? That is possible, but it is speculation. A civilization with larger telescopes and longer observation times might detect Earth's oxygen, methane, or seasonal atmospheric changes. It might classify our planet as a strong candidate for life. With extraordinary technology, it might even investigate signs of industrial activity. None of that establishes that such a civilization exists. It would also need to occupy a useful location, study the sun, recognize Earth, gather enough data, and interpret that data correctly. Distance adds another complication. An observer 100 light-years away sees Earth as it was 100 years ago. At greater distances, it would see an earlier planet, perhaps before our strongest radar systems or modern industry existed. So, could alien astronomers already know Earth has life? Earth has crossed the sun as seen from certain nearby systems, and our atmosphere contains a striking chemical combination that advanced observers might associate with biology. Technology would be more difficult to identify, though concentrated radar or atmospheric pollution might become detectable with the right instruments. The evidence supports possibility, not contact. We have no sign that anyone has found Earth, classified it as inhabited, or chosen to observe.